morning, first graders. Jack and I are back today to do another number talk with you. I'm actually recording these the day before you see them, so it's actually St. Patrick's Day today, which is why we're wearing our green and maybe gonna go look for a leprechaun later. Hopefully you guys have had a chance to enjoy some sunshine outside. So the number talk today that I'm gonna set up looks like this. Jack's gonna help me solve it and get his kindergarten brain thinking along with you first graders today. So here is our first equation we're going to have Jack solve. So again, as you guys are thinking about your solution or your sum in this case, since it's an addition problem, go ahead and pause the video if you need to think, and then you can listen to what Jack did for his strategy. All right, Jack, you think you know?
Mm-hmm.
Okay, what did you get?
18.
You got 18? Okay, how did you get 18?
Because 1 plus 8 is 9.
Okay.
And then I counted 9 more.
Okay, so you combine these to get 9, and then you kept counting?
Mm-hmm.
Okay, 9 more. And you got to 19. So Jack did a count-on strategy. He first,
Oh,
18. I went too far, didn't I?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. So he got 18. I also got 18, but I did it a little differently than Jack. Oh, my third grader wants to tell me what he did. So Patrick will tell us what his solution was.
So first I did 1 plus 9 is 10. And that's like the easiest, because then it makes 10 plus 8 is 18.
Oh, okay. So Patrick combined 1 and 9 instead, and then went ahead and added in his 8 more to also get 18, just like Jack. That was what my strategy was. I'm going to give Patrick an agree sign. I agree with you. But then it made me think of another strategy since Patrick did that one. This was Jack. This was Patrick. And then I'm going to go ahead and share one more strategy with you. If I started like Jack did at 1 plus 8 equals 9, then all I had to do was go ahead and add my 9 plus 9. And that is a double. And that is something our first graders have also been working on. 9 plus 9 is 18. So all three of us agree with 18. And that's the answer. Good job. Hopefully you guys came up with a similar strategy or one that you had on your own. Go ahead and share it with someone around you, and we'll see you tomorrow. Bye.
Bye.
Let's say that you want to count the days since your last birthday because you just want to know how long it's been. And so one day after your birthday, you put a mark on a wall. Then the next day, you put another mark on the wall. The day after that, you put another mark on the wall. So that day, you say, well, how many days has it been? Well, you could say, look, it's been 1, 2, 3 days. So one way to think about it is this set of symbols right over here represents the number 3. But then you keep going. The 4th day, you put another mark. 5th day, you put another mark. And you keep going like that. Day after day, each day, you add another mark. And this is actually the earliest way, the most basic way of representing numbers. The number is represented by the number of marks. So after a bunch of days, you get here and you're like, oh, well, how many days has it been? Well, you just recount everything. You say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 days. You say, well, you know, this number representation, it took me a little bit of time to realize that this is 17, but it seems to be working, so you just keep going. Day after day after day after day, you just keep marking off the days on your wall, just essentially counting the days since your last birthday. But at some point you realize every time you want to know how many days it's been, to count it is a little bit painful. And not only that, this is taking up a lot of space on your wall. You wish that there was an easier way to represent whatever number this is. So first of all, let's just think about what number this actually is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So you wish that there was a better way to represent this number, which we now call 37. And maybe when you're first trying, you might not have even called it something called 37. You would just call it this number of days since my birthday. I said, well, look, what if there was an easy way to group the numbers? I have 10 fingers on my hands. What if I were to group them into tens? And then I would say how many groups of 10 I have, and then how many ones do I have left over? Maybe that would be an easier way to represent this quantity here. And so let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a group of 10 right over there. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is another group of 10 right over here. And then let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is another group of 10 right over there. And then finally, you have 1, 2, 3, 4, 5, 6, 7. So you don't get a whole group of 10, so you don't circle them. So just by doing this very simple thing, now all of a sudden it's much easier to realize how many days have passed. You don't have to count everything. You just have to say, okay, one group of 10, two groups of 10, three groups of 10. Or you could say 1, 2, 3 tens. And so that's essentially 30. And then I have another 1, 2, 3, 4, 5, 6, 7. And so you say, oh, I have 30 and then 7, if you knew to use those words, which we now use. And this is essentially what our number system does using the 10 digits we know of. The 10 digits we know of are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what our number system allows us to do is using only these 10 digits, we can essentially represent any number we want in a very quick way, a very easy way for our brains to understand it. So here, if we want to represent 3 tens, we would have put a 3 in what we would call the tens place. We would put a 3 in the tens place, and then we would put the ones, 1, 2, 3, 4, 5, 6, 7. We'd put the 7 in the ones place. And so how do you know which place is which? Well, the first place, starting from the right, the first place is the ones place. And then you go one space to the left of it, you get to the tens place. And as we'll see, you go one more space, you go to the hundreds place. But we'll cover that in a future video. So this essentially tells us the exact same thing. This tells us the exact same thing as this does right over here. This tells us 3 tens. 1, 2, 3. 3 tens. 3 groups of 10. And then another 7 ones. So we could rewrite this. This is equal to 3 tens plus 7 ones. Or another way to think about it, what are 3 tens? Well, if we use the same number system to represent 3 tens, you would write that down as 30. And then 7 ones, once again, if you use our same number system, you would represent that as 7. So these are all different ways of representing 37. And hopefully this allows you to appreciate how neat our number system is. When even a number like 37, as soon as you just write scratches on the wall, it becomes pretty hard to read. And you can imagine when you get to much, much larger numbers, like 1,052, to have to count that many marks every time. But our number system gives us a way of dealing with it.